Good morning, everyone. Thank you for joining this month's Innovation Forum meeting. We're extremely excited to be joined by Marco Micheletti, who is the Director of Hardware for Fresh Consulting. Marco has a wealth of experience within hardware space, specifically dealing with robotics and automation. So I know he has a wealth of content to share today to give us a glimpse into the future of that space. And it's intended to be interactive this morning. So as he's talking through different topics, please feel free to chime in, ask questions, engage, and we'll have a very collaborative discussion around this. So without any further ado, I'll hand it over to Marco.
Thanks, Norman. Thanks, Kurt. Thanks, everybody at camp. I'm appreciative of the opportunity to talk today, and it's a really appropriate time, like we were just saying, in what's going on in the world. Yeah, happy to be talking about the future of robotics and automation. We've in the past thought of these as very different things, adjacent, but I would say the technology and where things are going today, things are getting closer and closer, and it's a really interesting time. So here's kind of where the journey I'm trying to take us on today. I'll do a little background on who's Fresh Consulting, a little bit of our capabilities. We have something exciting to talk about in terms of the Northwest Robotics Alliance, which was just announced and had its inaugural event 2 weeks ago. And then I really want to talk about the future of robotic and human integration and just where trends are going in that way. And there's some interesting points there that our leadership at Fresh have been able to put together and really help us think about how we form opinions around how people and robots and automated systems work together. And then we'll try to bring it back down. And so I would say that robot human integration is a very high perspective, zoom out, and then try to bring it back with some show and tell and some examples that are taking advantage of these types of technologies today. I have a lot of slides, so I'm going to go quick just because I don't want to read slides, but let me know if we need to slow down or take a pause at some point. So we're Fresh Consulting. We're really try to position ourselves as an innovation as a service consulting company. We're really broad in terms of our offerings, and I'll explain a little bit here, which is when I say broad and horizontal and have a wide array of offerings, we really like to start in the strategy practice area where we can really try to answer questions around what is the right product, what is the thing that the problem we're trying to solve, working through the design phase, and then software and hardware tend to be the actualizations of what we do. But these are how we organize our practice areas. And I mainly work obviously in the hardware space, where we have again focus in product development, manufacturing automation, autonomous mobile robots, test, and general robotic system integration. You can't think of us as the hardware team as a traditional full service product development company, but again, we have these specific, our history kind of points us in this direction of really leaning into manufacturing and autonomous robots and automation. A few of the clients, the big names in the area and globally as well. A few different numbers about Fresh. You might see 380 to 450. We're kind of in this, we're a solid medium-sized company. The important thing to keep in mind is that we have two halves of our business. I'm more in our project focus space, and what wasn't in the previous slides was where we have managed consulting services as well, where there's a large number of folks. So within our focus project space, where we're serving our clients directly and working on really high innovation type of products, there's about 150 folks or so. Fresh has been around for 14-15 years. We have 7 locations. We've just we have offshore, nearshore, Bangkok, Costa Rica. We have offices in our headquarters, obviously Seattle, Bellevue area, and then presence we've been expanding in the Texas space. From a hardware standpoint, we're, again, pretty full service in terms of what our capabilities and our team size allows us to address. We really like to take on essentially the hard, challenging problems out there in the product development, robotics, test, automation spaces, and help our clients work through really hard things. Again, from a robotics standpoint, we have folks that can kind of solve and address all the main types of problems. Same thing with traditional automation design and capabilities. Firmware, we're pretty deep on the firmware side. And a lot of the history of the team is developing custom and test equipment and test automation. And then we've also recently expanded, invested into developing RF capabilities and the equipment that's necessary for developing RF antennas and doing signal analysis and things like that. We also have, I would say, another one of our superpowers is we actually have a lot of capability around fabrication and small prototyping and building inside. We have a couple different options for between our labs and our shops with different types of capabilities. We have 2 labs in our headquarters that are about 2,000 square feet each, with benches and things like that. And then we have a 10,000 square foot shop across the highway from our headquarters in South Bellevue, which allows us to do some pretty large, you need the space when you're doing either mobile robotic integration on vehicle size products or large automation work cells. So we have a lot of capability in-house as well, which also differentiates from other folks in the area. So this is a little bit about, so why do we do this? We're really interested in really, the purpose of product development companies is to help our clients bring, commercially viable products to the market. And it's a really hard thing. Everyone's heard the hardware is hard, but that's what we are. We're hardware developers with a lot of capability in a lot of different areas. And we're just, I think at the heart, almost everybody on our team are just, we were all that kid that loves to build and tinker and engineer. And that's what we are at heart. And we love solving the really hard problems for our clients. And we follow, formal and organized processes around product development. We have some of our product development processes that we show. People have different terminologies for product development processes, but we follow that. We publish quite a bit in the space of thought leadership and papers, white papers that are on our site, always kind of trying to look around the corner a little bit into the future and show and bring to our clients and to anybody who's interested, just, a little bit of thinking around what are some of these new technologies and challenges and things going on in the future.
Marco, really quick, while you're on the topic of thought leadership, we had a question from the audience. Kurt put something in the chat, and he is wondering, how much time, money, and energy do you spend thinking about the implications of AI interfacing with robotics? You might have a white paper on that.
I think we probably do have a couple, we have like future of autonomous systems right here in the middle. And that's where we do have some of our folks that, like, in the robotics team will say, hey, this is a really interesting space, or someone might come back from a conference or talking with a client or anywhere and say, I'm really interested in this topic. I want to kind of take it a little further. And so we're really supportive of folks, that have the passion and energy and want to explore that. This is a forum for that. And then it demonstrates, hey, there's some great thinking here around how that might benefit our customers, it might benefit our partner, it might benefit anybody in general. So did that answer the question?
Yes, thank you.
Great. And along those lines, we also do it. Let me skip ahead one more. We have a podcast called The Future of, and I think it's another one of those opportunities that if there is a particular a deeper dive that we want to take into a topic with someone from the camps community, or if you guys thought, hey, we pair maybe someone from our team with someone from industry, and we say, let's discuss this, and we put it on the podcast. And that's something that we've done quite a bit. So I think that there's an opportunity there. I'm putting out there, if you want to follow up through camps or directly to me and say, hey, I'm really interested in this topic. Let's see if there's something here. We're releasing podcasts, sometimes multiple per week. So besides consuming white papers, there's podcasts, which is, great, different form. A little bit about the folks. We do focus in a lot of different areas. And so we, as directors and leaders in our hardware space, we each tend to try to follow a particular discipline as much as possible. I'm a little bit in the product development and automation space. Jeff Gable's our really traditional automation. John Perrin in firmware, Reg Orton in product development, and we're actually potentially in the hiring our new robotics director as well. So that's a little bit about Fresh. One of the things I wanted to speak to quickly, and not sure if folks have seen or are aware, but we are one of the charter members and have just announced the Northwest Robotics Alliance. About 2 weeks ago, we had the inaugural kickoff event, and some of the content I'm going to present later is from that event. We're really trying to form a robotics community in the Northwest, and also accelerate and lean into the speed and the growth and all the good stuff happening in the robotic space, and help being an enabling factor in that space. There's a little bit of history. There's a number of actually kind of pretty famous already nonprofit or robotic based organizations between Massachusetts Mass Robotics, Pittsburgh Robotics, and Silicon Valley Robotics. So we're really trying to continue in the vein of these community organizations, and further the model a little bit to again, support and enable the development of the robotics industry in the Northwest. There's obviously great reasons why the Northwest should have their own organizations. We have a number of large cap OEMs in the space, tons of leadership. Geography alone is always an interesting factor in why the Northwest is special, and probably how it's developed economically over the decades, just because of, literally, if you look at Seattle, Portland, Vancouver, there's a 1,000-mile gap between us and other metropolitan areas. And so it makes sense that we try to support and recognize just the area, and try to, let's say, not put our hands around it from an exclusion, but again, trying to lift and support. There's a little background, and again, in why we thought this was the right time. There's a number of companies that are actually, there's just a little research behind why and why it makes sense to do this. But there's a ton of opportunities in the Northwest companies in these diagrams. And again, what we're really trying to do is create an ecosystem where we're helping robotics companies get over some of the humps that are challenges that they face as young companies. So we're trying to create standards, trying to create open source opportunities where folks aren't duplicating efforts in a lot of ways, and just providing again a full service organization that can help in a number of ways. So here's essentially the mission and some of the partners. What again, it was Fresh played a major portion in bringing this up and finding the partners to put together. But we have a lot of great partners that have also leaned in and contributed, between Cascadia Capital, Madrona Venture, Microsoft, Amazon and the University of Washington, but even also extending out into, Oregon State and some of the other universities and partners in Canada, as well as in Oregon. A lot of these folks actually are at the Pittsburgh event this week. Anyway, that's a little bit about the Northwest Robotics Association Alliance. Sorry, I'll have a link later. You can look at the website. The first event was just 2 weeks ago, and there'll be future events coming up. Okay, so this is, I think, the main thing we wanted to talk about. And again, there's a few slides here I really want to go quickly through and dwell on a few of the ones that resonate with me. This was a really fantastic presentation that our CEO, Jeff Dance, gave at the Robotics Alliance kickoff. And it's a great zoom out, I think, that helps put the time we're in and the technology we're seeing and the development and the speed and think about how these things really impact us as people, as humans, and what are these interactions between devices and machines, and what does this all mean? And I think these are questions that I would say, me speaking as an engineer, don't always bubble up and stop and think about. And I really appreciate this perspective that the other people in our company, and again, why we have this breadth and these people that think strategically and are thinking about what the implications are to society, not just, let's say widget builders like me. It gives us a really great opportunity, and I think a lot to talk about today. So this is kind of exciting for me to run through this. So what we're talking today is a little bit about the human-robot relationship, and where this really somewhat took root for us was with a product we call Harmony. We did a project, and we'll show some autonomous tractors rolling around here. But the seeds, I think, were planted about 3 to 5 years ago when we were talking about how do you orchestrate, really solve the engineering problem of how do you orchestrate a number of robots working in a particular space where people are as well. And so if you can imagine that, that's actually, quite a hard problem to solve beyond just a lot of the technical issues. So, we were deploying a fleet of about 85 autonomous vehicles, or 78 there. And that was, a really challenging problem. But these are things that you see. So these are going to be examples that you see today where people are solving similar problems in very complex space, such as robotic surgery. And we also got experience and exposure a number of years ago when we were working on when Microsoft came to us and wanted to talk about a product that was taking advantage of reinforcement learning in a particular type of AI model from a company and IP that they acquired. And then, we see other applications out there where people thinking forward, where there's just these, other opportunities where there's just like really interesting capabilities and thoughts people are having on how we want to use robotics to help people or solve a particular problem. And some of these are just becoming really real these days. Some interesting things to consider is that, we see 6 or 7 or 5 or 6 degrees of freedom, robotic arms, but a hand has 27 degrees of freedom. And we'll kind of let that sit for a moment. There's computer vision that's really powerful, but the eye and the brain have tons of capability for processing sight and images faster than even text. And so the brain is just a tremendous tool or machine or computer in itself that's been developed through evolution for taking in a lot of what we see in our environment. And when we start talking about the differences in robotics and automation, one of the big factors is we talk about constrained environments or open environments. Humans are really well adapted with our articulation of our legs, feet, ability to take in images and process a lot of ambiguity. Walking, like take the example of walking across the street, is actually a really hard problem to solve for a robot. There's a paradox that says that, reasoning, logical reasoning takes very little computation if we're really breaking it down to, it's ones and zeros, right? And that's the original power of computation. But sensory, motor, and perception, and dealing with everything that's in an environment, it really requires enormous computational resources. And this is part of the reason why we're talking about this today, because some of these resources are becoming unlocked. But, from a traditional standpoint, robots rolling around in the world is just in real time and adapting. It's just a really hard problem. So what we kind of position we start thinking about is, you want to apply strengths to situations where they're best suited, and not expose a weakness necessarily. And so things that humans are incredibly positioned well to do are to be, we're creative, we have a complex brain, we can think very strategically, we can adapt to the unexpected, we have a high degree of dexterity, and we have our emotions and empathetic and can be sociable. Places where we potentially have deficiencies is, we get tired or bored, we get sick, we have emotions, we can be irrational, we have limited memory potentially, or we can be forgetful, and we can have particular sensitivities or be fallible in some situations. But let's look at this and say, like, well, what do robots do well? Well, they can work continuously for long hours. They can be durable and strong. They can come in many sizes. They can be reprogrammed. They can potentially be inexpensive for routine tasks. They can be exact and precise and logical. And if needed, can be destroyed. But what they don't do well is, actually provide, they lack judgment and supervision. At times there's needed for intervening when things go wrong, and there's situations where they can't adapt to. They're limited in their senses, not as dexterous or mobile. Potentially the interactions with people, can create tensions. There's development and costs with, learning and teaching and applying them, and they're made to do sort of like one thing. So there's a lack of creativity. So the position here, the thinking that Fresh is really, leaning into again is like, how do we combine strengths and weaknesses? We think that, the future is together working with technology ultimately. So we need to have, a framework this is essentially our framework for how we do this. And traditionally, robots have been, tasked with the dull, dirty, dangerous. It's a really traditional way of looking at it. And then, dull of today, yesterday isn't the same. But one of the things that came out of the pandemic that we believe is that, people want more meaning and growth in their lives. And we think that the trend that we're on is potentially, beneficial in that we can take some of that autonomous, mundane and repetitive and the dull, and try to offload that to the robotics. And then we also see, obviously, labor shortages in a number of places also, fueling the tailwinds and the accelerations of development in this space. Clearly in these industries, constructions, restaurants, transportation, logistics, and manufacturing. I have some examples of these later. So this evolution and potentially fear is not new. We've seen this, in other technology cycles. But we look at this and you look forward and you say, machines could displace a lot of jobs, but we also think that they're going to create new jobs as well. And what we're really looking at is how do we do this in a way that helps, utilize automation and robotics in a way that that benefits people. And again, a little bit more on the thought leadership, but these are 10 different podcasts on different aspects of automation, and robotics. So again, this is really essentially our position is like, how do we let humans be more humans, which inevitably means being more creative, more innovative, more social, and do more meaningful work. I'm going to try to click ahead here a few more. There's some this is starting to get into examples here of just some of the news articles. We talked a little bit at the beginning, maybe right before we actually started, but obviously, what is the role of AI in robotics? There's this huge acceleration in what's happening based on generative AI, the chat GPT. We were just talking when we started, people I've listened to in the space have talked about the speed at which this is evolving in the last 6, 7, 8 months is unprecedented, and it's outpacing applications and products that are actually taking that are able to take advantage of that type of technology. And so just again, some facts, it's amazing how fast. It's one of the fastest growing products that there ever was. And it was just a simple text interface and a lot of other ways to make it really simple. I want to also, again, these are just some of the other devices where we've seen just it used to be AI, the first thing we saw was really voice interaction, but now we're going to start seeing in a lot of other places. There's an interesting quote that Bill Gates said that we kind of have adapted, which is that we generally overestimate the change that'll occur in the next 2 years, and we can say this in the next 3 months potentially with AI, but underestimate the change that will occur in the next 10 or potentially a year. And I think that's an interesting thing to take away perhaps from today, is just to be mindful of what's happening in the next year or two around you and in your space. But again, examples of products that are out there. These are some just the early first products that are taking advantage of these AI. And so these are the folks that have been on the forefront. But how do we translate this back into, what's happening in, say, robotics and automation, actually getting it back into hardware? These are just a few more products that you can see out there. Some of these are really cool. Like if you go to Meta, I don't know if anybody's seen Segment anything. A lot of this stuff is just right now available on the web. You can just like ChatGPT, you can go to Facebook, look for Sam, and upload a picture, and the capabilities around the AI it's real time, and it's amazing. I think at this point, I want to stop. I'm going to click a few more slides here, but I think I want to stop here because this is where we can kind of bring it back down into some of the spaces around robotics and automation where I've seen some real applications. So let's see. I think we'll stop at this point, and it's a good point to say if there's any questions. Give me a moment to switch back to some of our other.
I have a question for you, Marco.
Sure.
So I think one of the reasons that small manufacturers will hesitate to implement cobots or robotic arms on their manufacturing floor is the perception that the time it takes to program the job would exceed the amount of time to just have a person do it. How do you feel about that? Has that really come quite a ways over the last couple of years?
Yeah, I think that actually might be a perfect segue, actually.
Awesome.
As an example of that.
Let me go to our project examples and get some of our links. So I agree. First, I agree, I empathize, and I understand, and I think that what these technologies, what I think I will show you here in a moment, and I'm just gonna go to like desktop display, so it's a little easier for the moment. The ROI, essentially the ROI has been really difficult to, especially for smaller manufacturers, to justify. You really have to see the benefit. You really have to get in there. You really have to be solving the right problem. So this is something I see and deal with, let's say, every day. And sometimes, and I have another example here, it's just maybe beyond a threshold that a small medium manufacturer, let's say traditionally, could deal with. But there's things happening here which are just amazing. And let me see if I can get this bar out of the way. That are totally changing the economics of this. One company, I would say, that just as just an example, and there's a lot of people doing this. Apera, these were folks from British Columbia. They came and presented. They're essentially a vision process. We didn't talk too much about some of the underlying technologies that are powering AI, but it's basically, it's the cost of compute has gone down, right? It's the NVIDIA, the GP, it's the discovery that vision and you can model AI problems in software, and a GPU, which is different than a CPU architecturally, is what they call embarrassingly parallel, and it can solve a lot of problems in parallel, which are well beyond my understanding, but it enables you to code and essentially run and solve AI problems in near real time. And those products, essentially GPUs, were developed for video game image processing, and the discovery that you could, graphic processing, that you could use these to solve these types of problems, was really the inflection point here. And so now you have a technology that's basically been already driven down the cost curve, and is accessible globally and in scale. And now the software and the applications are really starting to catch up. And that's kind of what's happened in the last, let's call it 5 years. So this company, Apera, a lot of these folks, you come in and you don't have to, say, use the traditional automation approach, which is like really controlling all the environment. The AI, the vision processing, is allowing the robot or the software to deal with the ambiguity of this bucket of parts over here. Where before you had to have everything really nicely lined up, you have to code it all very specifically for the application. Now you have this, like, the 2 cameras up above. It's really simple hardware. There's nothing really special about them. There's like a PC or an NVIDIA type product that's not very expensive over on the side. And it's just really driving this whole thing. And so some of these applications of what you can do did take a lot of development and coding and investment up front. And this is where the cost has come down, by orders of magnitude. A lot of this is essentially, you do a little bit of training, and there's examples here where they're moving this around. This is happening this is like unprogrammed, essentially real-time, open-ended running type robotic application. This is dealing with it doesn't know where the target components are. It doesn't really know where it's going. You could move it around and it'll find the right spot to sit it in. And this is really amazing. Like you can go buy this product, put it on one of your cobots or any other robot, and it like just works. And these guys are saying like, well, it'll just keep doing this all day long and operate at a night. And you'll see it might drop a piece too. And you don't have to stop and clear it. Like I ran a factory that anytime something dropped and ended up in the wrong spot, it at worst shut the machine down or caused a crash that could have been tens of thousands of dollars. But at best, it just stopped if it detected it. And you would take some type of intervention. But look, it dropped, it missed. It's like, it's okay. I'll just keep going. And this is the type of stuff that's happening now that you don't have to spend time developing. Someone's already developed it and they're taking these things out at scale. This is what's bringing the cost down. The other side of it, the hardware side. Here's another example, actually. This is our former director of robotics, Mitch Tolson, but he started a company called Ally Robotics, and they're just really trying to make a low-cost robot arm. But oh, by the way, they're teaching it with hand controls, so that you don't even have to. So you can just teach the points. And a lot of people are solving different aspects of these challenges of how do you get over these hurdles of things that have to be deeply coded and take a ton of resource up front. The whole industry, people are working on the vision problems, the AI, the decision making, the open-endedness, and scaling that out, as well as the hardware side, making lower cost arms. When I worked on a highly automated factory a few years ago, I think, and just an Epson Scara that moves back and forth is about $25,000-$30,000, and today I think they're like $10,000 to $15,000. So everything's coming down. The application, this is just another interesting application of this is a food service. This is deep fryers, a company that wants to no one likes sitting in front of the deep fryer, and this is a company that we've worked with. But creating, the robot arm, the system to be able to monitor, do all the things you need to do, but also do it economically. The low cost arms that Ally are making are in partnership with this company so that they can address the cost of installation for all of these things. Now, again, I think when we talk about the camps community, we do need to be very specific and really think about how to solve the right problems so that, automation can get expensive. And just for the opposite end of the spectrum, this one right here. This is a mega distribution center. A place, actually, I went and saw this working in person, and they take pallets of products from Procter and Gamble or anybody, and they depalletize them, store them in a huge cube, and then as stores or people bring their orders in, they build. Again, this is the inbound process, and just destacking and ingesting pallets of the same product, storing them away. And this is real time. These are huge robots processing tons of stuff in a 1.2 square foot warehouse. So we're talking a large consumer goods distribution center. But what they're able to do is when they're building their orders that for pallets that go out to the stores, Let me see if I can forward along to this. This company is called Symbotic. This is the racks where they're stored, so they can store things actually more densely. They can retrieve it. They have a number of different, it's still a little bit, a lot of the part of the solution is still a little bit of brute force, robots going back and forth. But the fact that they can, and actually, I'll talk about the efficiencies of what they're driving. It's amazing. The company pledged $13 billion to automate all of their distribution centers in this way, which is essentially from unloading the back of a truck to loading the truck with a new mixed pallet. These robots, the AI, the computer system can look at the orders. There's a couple of things going on here, which is amazing. They can build the order for the store so that when this pallet comes off the truck, they know that the things on the top are going to go to aisle 1. And as you go down the aisle, they'll be put it on the shelf. And as you go down to aisle 2, the next thing. So they build the order in a logical sense that's efficient for restocking the shelf. But also you see it's stable and it's more dense than anything a human can actually do. And so this is where, let's call it the computer, the AI, or the optimizations that they can make based on the order really come into play. So again, this is more of an industry leader, and what they were able to do, they understand their costs and their operations so well that they understand every time I touch a box, it costs us 50 cents. So it costs us 50 cents to go put it away. It costs us 50 cents to put it back on a pallet. It costs us 50 cents to take it off the pallet and put it on the shelf. And they were able to build their ROI that essentially said, we can invest $13 billion, and we're cutting our touch cost in half. And so, the thing that enables it for them is that they're doing something like 500 million touches a day. So, but the ROI was there for them. My point is that it takes that same level of focus to solve, understand that you're solving the right problem. Now, this is a massive endeavor. It's an end-to-end solution, but it applies obviously if we're turning a screw or we're packaging or places where I think these technologies might be really applicable for folks in the community are some of the machine. Let me go back to, I think I had that machine tending video that we were talking about. Or here, here's a sorting application. Sorting small things that, just dump them on a table. And this is kind of 2 or 3 things working together. It's a really fast pick robot. There's clearly a camera in here too that's driving and telling it what to do. And then there's this really simple sort table, but you don't have to worry now about mixing part A and part B, or keeping them separate, or putting them in really special constrained places or crowded. You just let the vision, it's the power of the vision, or the AI is detecting red, blue, orange, green, round, circle. And we had an application that we were literally we have 3 different washers essentially, and they differ in diameter by 2 or 3 millimeters each. But we said, we don't have to worry about putting them on spindles or sorting them really, really precisely, because it's at the detection level of the camera systems along with the AI. We can measure them to within a tolerance that we can always pick the right one. So that's a place where, sorting, placing into packaging, labeling, applications like that, which become very monotonous for people to do, but are great starting point applications for for folks in the camps community. And there, you know, speaking of that, there's another company, I think it's this one, iVault. They're developing a more of an anthropomorphic robot, and I don't know that it looks something like this, but the point is that it's easily trained. And one of their applications, you kind of see over here, I don't think they have any videos, but is label application onto a bottle. This is a local Seattle company that just came out of stealth. But what they all have is an ability to kind of avoid this custom coding, take advantage of again, the power of the AI or power of the computing to abstract the things that used to be hard coded previously and get past that investment up front of developing a highly custom system. And that's the other great thing. It's like, oh, we're going to use this for labeling today, but machine tending tomorrow type of a situation.
Marco, I see on this slide that they're emphasizing their no code platform. And are you seeing that more and more with automation and robotics, that this idea of no code is the way things are going?
Yeah. I would say, you know, back in the traditional automation is like the PLC, we're going to program logic that's going to be very repeatable, closed loop, deterministic. And now with either a little bit of training or some type of, let's say, shortcut, the no code is we can go deploy it, and with a few iterations of training or providing the right inputs, we can go to we can get a functional system quicker.
And to me,
I don't know what no code means, but it really means we're not going to sit here and custom develop something just for you. You've seen this has been a software problem across the industry for sure. A lot of companies have taken and created products that take, let's say, like pendants. Maybe a UR pendant, you still kind of have to code, and they made it somewhat visual. And some companies have taken it and said, we're going to make one pendant to interface with them all. Whether you have a UR, a FANUC, or an Epson, we'll even abstract a layer higher so that you can work with all three of them in one type of device. And these are just continuations. You know, no code is a continuation of that. And like Ally Robotics, they want to use hand prompts, and there's no coding. We're teaching points based on the camera taking prompts from a hand.
Yeah, so, Mark, I was wondering if this might help answer Allison's question of in these high mix environments, and this goes back to Hans asked a question earlier too in the chat about, you know, why is there such slow adoption? But I wonder if maybe the perceived ease of use thing, where Allison was saying, you know, when I consider how much time it takes to set one of these up and program them and get it all going for a short run, you know, it's easier just to have somebody do it. But now I'm wondering if what you're just saying about no code is a little bit of a game changer for high mix manufacturers.
It is. And you know, a lot of these, you know, it's a little bit of the Wild West there. It's all coming out, and it's so new that we don't even have some of these. We're kind of like, if I go back into some of our examples, you really have to have the need and say, like, I'm going to invest in. Actually, the really interesting thing about cost here is that these folks have a pay-as-you-go business model, which I haven't seen anybody be extremely successful at this yet. But also for people in our community, in the camps community, we really have to solve also this cost model so that we aren't sticking folks with the upfront. Regardless, there's an upfront cost. I've been noodling with people. I've talked with some of our banking members at camps. traditional bank, it's like, these are models that are evolving. The financial aspects of this, have to be dealt with, and it's going to take people innovating in new ways that will be able to support this. And I was at an automation conference about a month or two ago, and was talking to someone in the finance space who was, let's say, more in the Wild West, saying like, I'm here, I want to specifically invest and support, let's say pay as you go or robotics as a service type models, which again have taken foothold in some places, but haven't developed fully, and we haven't seen huge successes quite yet. But it takes people like this to go out and try, and all of this is just really new. So you do have to take a measured approach. If you're going to be an early adopter, you have to convince yourself that like we're going to stick with it, that we have the right problem, and we're very convinced of the ROI. Now, the other thing that the ROI calculation has changed dramatically. It used to just be, if I take one person away, I need to be more efficient. That costs directly. If I save $50,000, I can only spend $50,000, or whatever your timeline might be. But when earlier in the presentation we talked about, well, we're missing opportunity cost also, because if folks aren't showing up, or I can't staff second shift, or I'm always trained, like the cost of training and rehiring itself is quite expensive. And I'm getting inconsistent quality, and my brand or reputation is suffering. All these things really need to be considered and accounted for in some way or another, because they do add up when we're talking about jobs that are hard and generally not interesting, and a lot of folks aren't motivated to just stick labels on the side of a box or load the same widget next to a machine over and over again. And so you really have to look at this and really do the right level of diligence to convince yourselves that whatever you invest is going to work out.
Marco, as you were talking, it occurred to me that the way we now look at ROI, you talk about those missed opportunity costs. It does seem like there's going to need to be a more sophisticated way, or somebody's going to have to show us how to, maybe not that we have to get convinced that robotics and automation will help solve our problems, but we probably just need a little bit more hand-holding on how to think it through, how to look at the ROI, because I think with the ease of use, the increased capability and the lowered costs, I mean, it's starting to become a no-brainer. But now just, where is this going to have the biggest impact in my shop?
Yeah. And I guess, I think that's where we talked about, come talk to us, and we're happy to kind of walk you through that as well, and kind of be advisors, or just me at a personal level. I'm available to the camps community, and I love talking about this. It's the make or break when we're developing our solutions for company. Like, I don't want to pursue an opportunity until both sides, us as well as a potential client, are convinced that there is an appropriate opportunity, and when we both agree on it. We had a great conversation with a client last week, and the opportunity cost of just a 25% incremental output increase was $10 million. They're like, we don't have space to expand. We can't get people on the second shift. It's easy for us to say we can just add a few more people, but the reality is we can't get the people, so we can't bank on having the capacity to get that 25% increase in output that we know we can sell. But the impact, if we could sell it, just from a margin standpoint, is $10 million. That's opportunity cost that they're missing right now. That's not the cost of just eliminating the head. But those are things that I'm happy to, I love having these conversations. So reach out if that's something you want to talk about. We're close to the end of time. And I also mentioned, we're looking forward, I think, for opportunities to come potentially visit Fresh. We have a work cell that's not quite being built yet, but I think that'd be a really fun thing too, to look at and talk about. We have some great things, and it'd be fun to have folks through our shop as well in the future.
Well, Marco, we definitely appreciate that open invitation. We'll be sure to link your contact information in the video description. But thank you so much for taking the time to speak with us today, shining a light on what's possible with robotics and automation, as well as giving us a better idea of potential use cases that are within reach for the CAMPS community. I know I learned so much just watching these videos and talking with you. So thank you again for taking the time. For those who attended, also appreciate you making time to join in. If there's any questions that may pop up, again, we'll put Marco's contact information in the video. We're finalizing the topic and agenda for our next meeting, which will be the first Wednesday in June, same time as well. And we'll be sure to get that announcement flyer out as soon as we finalize those details. And as always, if you have topics, questions, a passion project that you're working on that applies to innovation, please feel free to reach out to myself or Kirk. And with that, thank you again, and hope everybody has a great rest of your day.